there! Have you ever had that random pop-up question in your mind, wondering what's really inside the coconut? I mean, think about it. We often know that there are liquids and solids inside, but what's in it for us? Is it only for buko juices? Well, today, we're going to unravel the components of coconut milk and use those components for something very thrilling. Without further ado, grab your coconuts and let's unveil the secret hiding inside it!
Coconut milk is actually a mixture. It has water, oil, and coconut insides all blended together. Our goal today is to separate these parts and examine their properties down to the molecular level. Sounds exciting, right? Who knows what amazing things we can make out of with just a simple brown coconut?
Before we start, here's what we'll need. 1 or 2 meter cups. 2 liter or kuran as we call in our native language. 3 a bowl and a clean cloth. 4 a pot or pan. 5 on the stove or burn.
Step 1. Grating the coconut. Of course, we first need to pry open the coconut that we have. By doing so, we would want to acquire the small coconut shreds. This will later be used to extract the coconut milk. Reminder! Be careful while doing this and ask for help if needed.
Moving on, we add a small amount of water in the coconut shreds and gently squeeze to extract the coconut milk. Use a clean cloth and then squeeze it tight. Like this. See that white liquid? That's fresh coconut milk, which has a rich mixture of oil and water.
Now it's time to bring up some heat. The coconut milk is poured into a pot and heated over low flame. For this, let us activate our 5 senses and observation mode as scientists. Watch closely. There is a time when the mixture appears to be having a thick cloud on top. As it boils, the water evaporates and the oil starts to appear on top. That's the separation of components in action!
Can you see the oil now? That's coconut oil forming right before our eyes. Keep stirring until the oil looks clear and the residue turns slightly brown.
Yes! Now let's separate the oil from the residue using a strainer. Look at that! Pure golden coconut oil. Meanwhile, we can also see a brownish residue at the bottom. Shockers!
I wonder how we come up with this stuff. Anyone from the group who wants to explain the science behind it?
Me. I'll explain this. Okay, so, as we all know, coconut milk is a mixture, right? It is composing of oil, water, and the brown residue. And we all know that mixtures can be separated through physical means. Well, in this case, emotion, density, alongside applied heat help us to extract the individual components of coconut milk. Remember the time when we put water into the coconut shreds, and then after this, we squeezed it, right? Coconut milk mixture is actually an emulsion, meaning it is composed of oil and water. And as we all know, these two do not mix. And this is because that water is a polar molecule, meanwhile, oil is a non-polar molecule. Taking into account the density, water is denser than oil, meaning, therefore, it will sink to the bottom while the oil rises. And also, taking into account the boiling point, water has a lesser boiling point than oil, meaning it will evaporate quickly. Thus, this is why the coconut oil stayed in the pan. On the other hand, you notice that brown residue, right? Well, this is actually a product of chemical change. When heated, the water evaporated, right? And then protein and sugar actually are concentrated. They clump together, that's why we see them form as solids. As the heating continues, the natural sugars react with the protein, thus giving us that browning color, that brownish texture, and even a roasted smell. Moreover, in relation to macromolecules, each component is rich in their own ways. For example, the oil extracted is actually rich in lipids or fats and even cholesterol. Meanwhile, the brown residue is rich in proteins, and also the natural sugars from the coconut is rich in carbohydrates.
Alright. Enough of that nerdy talk. Time to create something meaningful, something useful with these individual components.
Okay, so, example, for SDG 2 or the Zero Hunger, we can use oil as a sustainable food source. Let's put our coconut oil to the test, shall we? Pour a little into a pan, add some popcorn kernels, and cover it up. Listen carefully. Pop, pop, pop! There it goes! Science just turned into a snack. That's applied chemistry right there. Now you and I eat popcorn kernels while watching the rest of this video. Want some?
Oh, I get it. Okay, moving on. I'll try explaining this next part. Okay, so for SDG 9, we can turn our components into processed products with the help of industries. Did you know that the coconut oil we've extracted is not only applied for foods, but also for commercial and industrial items? When processed properly, we can turn this coconut oil into this, an effective body skincare product. Not sponsored, by the way. Anyway, use this for a better moisturizing effect for our bodies.
Exactly! And lastly, for SDG 12, the responsible consumption and production, did you know that we can turn the brown residue into latik? It is one of the most famous delicacies here in the Philippines. Very yummy dessert.
Wow! Can you believe that? From one coconut, we found oil, water, and even yummy brown latik. See? Science is hiding in our kitchen. Fats rise, proteins change, and magic happens. Let's give a cheer for the amazing coconut. Small but super scientific. Thanks for joining us in our journey and keep exploring science, one coconut at a time.